Hello everyone. In this section, we are going to study the rigid bodies. We have already studied mechanics of a point mass. In these studies, we are going to consider the size of an object. So when you observe the collision of the two ping pongs, for example, if you have two ping pongs, first ping pong hit the other ping pongs, then you might observe the other ping pong is moving, but also the first ping pong also keep moving. When we study the collisions of the two objects, when the one object hit the other object, this object actually velocity becomes 0, and the other object has a velocity of the v. Actually, we cannot explain the motion of the first ping pong. This ping pong keep moving with a slow velocities, but still keep moving. To explain the motion of the first ping pongs, we have to take into account the size of an object. So we are going to study the rigid bodies in this section. First topic is the rigid bodies. We have to define what is a rigid bodies. Second topic is the equilibriums. And the third topic is the dynamics. So first topic is the rigid bodies. Second topic is the angular velocity and acceleration. And the third topic is the linear velocity and acceleration. And the fourth topic is energy in rotation motions. And the fifth topic is the moment of inertias. So we'd like to define rigid bodies. Rigid body is defined in this way. There is no deformations. Rigid body is not deformed by external force. So rigid body is an ideal object. There is no deformations. The body has a perfect, definite, and unchanging shape and size. So distance between any 2 points in a rigid body is always the same because there is no deformation. So if you pick up the 2 points inside of the rigid body, this distance doesn't change. Always it's the same distance. So we consider the motion of an extended rigid body in this section. So this is the definition of the rigid body. So we'd like to consider the rotational motion of an object. We'd like to define the angular velocities. So to consider the angular velocities, when the object is rotating around this axis, then this is the axis of rotations. Okay, so when you consider the rotational motion of a rigid body object, we have to find the axis of rotation. In this situation, this is the axis of rotation. The angle is changing with respect to the axis of rotations. So delta theta divided the delta t is going to be the definition is average angular velocity is defined the delta theta angle divided by times. The interesting point for the rigid bodies. Every part of the rotating rigid body has the same angular velocities. So in this cases, you can choose this cross mark. Also, you can choose, for example, this circle point. This circle point is moving to this point. For example, it's moving. Then this is also same delta theta. So this is delta theta. So every part of a rotating rigid body has the same angular velocities. All the points inside of a rigid body has the same angular velocity of the omega. So in this situation, I define the instantaneous angular velocities by taking the delta t is approaching to the 0. So by using the definition of the average angular velocity, we could introduce the instantaneous angular velocities. And the instantaneous angular velocity is same order point inside of our rigid bodies. So we have introduced angular velocity vectors. So we define the vector of angular velocity of the omegas. If you consider the rotation and motion of the rigid body object, this object is making a circular motions around this axis of the rotations. Angular velocity is directed toward the positive z directions. So you can follow the motion of the object using the right hand. Then some point in the direction of omega. We call it, this is right hand rules. We introduce the instantaneous angular velocities. Then we could also define the angular accelerations. Average angular acceleration is defined by the delta omega, is a change of the angular velocity divided by delta t. This is the average angular acceleration. Also, we could introduce the instantaneous angular acceleration using the limit delta t is approaching to the zero. We can define in the vector forms. Angular acceleration vector alpha is defined the limit delta t is approaching the zero, delta omega. Omega is the angular velocity vector divided by delta t. The rotation of a rigid body is speeding up if alpha and omega has the same sign, same direction. But it is slowing down if alpha and omega has the opposite sign, opposite directions. Okay, this is the end of this session.